So I'm going to go through the answers to the Unit 5 study guide with you. I'm going to go through it fairly quickly so that this video isn't too long, but you are welcome, of course, to pause it or back it up or ask for some questions if you need a little bit more help. So when you are given a value for cosine, you want to remember what that ratio is, adjacent over hypotenuse. You're going to need to sketch yourself a triangle, call any angle theta, label adjacent over hypotenuse, find your missing value. Here we found this value to be 5, and then you're using those values, your 5, your 13, and your 12, to go ahead and fill out these ratios. For the next problem, you are trying to find the value of the x. And so here what we're going to do is we're going to go ahead and label the angle that we know, label that your theta. Across is opposite, next to that is adjacent. Opposite and adjacent is the tangent ratio. So you're going to set this tangent ratio up. You're going to cross multiply. In this particular problem, to get x by itself, you have to divide. So what you enter on the calculator is 11 divided by tangent of 48, and that gives us our solution. For the third problem, let's get that straight. There we go. You can make a sketch. It does not need to look like this, but you can make a sketch of this. Here I have the tree house at the top of this. Here's the ladder. It says the ladder makes a 75-degree angle with the ground. So your angle is going to go, here's the ground and here's your ladder. So your 75 goes down at the bottom. The height of the tree house is what you're trying to find. So this is your x value. This is the ladder. That's the hypotenuse. That's 10. So from this angle, theta, we're looking at the opposite and the hypotenuse. So you're going to use your sine ratio. Set this up in cross multiply. This time you are just multiplying 10 times 75. If your calculator is giving you some weird value, just make sure that you're in classic mode. That's going to give you that decimal answer that we are looking for. All right, so on to target 5B. Here we are looking at changing angles from degrees to radians. So when you multiply by pi over 180, you're going to be changing from degrees, and your radians answers is going to have a pi in it. Again, if you're using the calculator and you want a fraction, then you want to put that back into math print mode. Here, if we're changing this to degrees, we multiply by 180 over pi. Think about those pi's needing to cancel. Your degree answer won't have the pi. That's 180. For here, you're going to be sketching these two angles. And so 300 degrees is down here in quadrant 4. And the gap between the nearest x-axis and the line that you drew is 60 degrees. That's your reference angle. To find coterminals, remember you are adding 360, minusing 360. So these two angles here are other names for this exact same angle that's drawn. Over here with radians, 2/3 pi, that is more than a half. Right here's a half, here's 1 pi, so 2/3 is up here. The gap between 2/3 and 1 pi is 1/3 of a pi. In degrees, that would be 60 degrees. You can find your coterminal angles by adding 2 pi and subtracting 2 pi. And for this section, again, you will have a calculator, so you can use that to help you out. Here, we're going to be listing 6 trig values for that particular point, so you want to make a sketch. I've got this sketch here. Here's my -3, -4. I'm down in quadrant 3. I've labeled my x and my y. Use the Pythagorean theorem to find the value of the hypotenuse or the radius. And then you are just listing out those ratios. Remember to use the negative signs. Here I simplified and that became positive. And then cosecant is just the flip of sine, etc. So you're finding those values. All right, we're going to move on to target C. This is the one you will not be able to have a calculator for or a unit circle. So I will give you these two triangles, the two special right triangles. So you're going to start with a sketch. So we've got 330 degrees. The difference there from 330 to 360 is a 30-degree angle. So I'm using this triangle, and I'm filling in those values, the 1/2, the radical 3/2, paying attention to the fact that because the y value is going down, this is negative. And when I'm looking for sine, I'm looking for the y value. I'm looking for the y value. And so the answer here is -1/2. The next one here, this is radians. 4/3, this is more than 1, 1 1/3. 1 1/3, here's 1 pi. Now I've gone a little more down here. So this is going to be the difference between 1 pi and 1 1/3. So this gap here is pi over 3. And pi over 3 in degrees, if you need to change this to degrees, you can multiply by 180 over pi, and that's where we can get that 60 degrees from, this 60 here. So I'm back up here to this triangle in the top right-hand corner and filling in these sides. When you're looking for secant, you are looking for the reciprocal of cosine, which is your x value. So I'm going to take -1/2 and flip that over. You can write it as -2 over 1, or you can just say -2. For cotangent of 3 pi, you do not need a triangle, you just need your sketch. 3 pi is going to land you over here. You can take 2 pi away from that like you would to find a coterminal angle. That's 1 pi. This point here, because the radius of our unit circle is 1, I'm to the left, so I've got a -1. I'm not going up or down at all, -1, 0. And cosine is always the x value. So our answer is just going to be -1. This question was a little different. Oops, let me move this over. And so this is asking us just to think about where values are on the x and y axis. If you think about the signs in quadrant 1, both of your signs there are positive. And so all of your values, sine, cosine, and tangent, they are all positive. In quadrant 2, we start with a negative. That is because we're moving to the left. Then we go up. That's our positive. So sine is the y value. That's the positive one. Remember that tangent is y over x. And so if you are going to put your y value over your x value and you're dividing a positive and a negative, you do not get a positive for that. So sine is the only positive in quadrant 2. Down here for tangent, or down here, sorry, for quadrant 3, these are both negative. So neither sine or cosine is positive. But when you divide a negative by a negative, you do get a positive. So actually tangent, positive in the quadrant 3. And then lastly, the signs in this quadrant would be positive and negative. Cosine is the x value, so cosine is the positive value in quadrant 4. All right, now let's take a look, and we'll go up here to the graphing target. This is target D. And so here we are just describing. This is not asking us to make a graph. So we want to look for the values here. A, this is the value of B, this is H, and this is K. So it is not just identifying that, as I've done here, but also saying what those things mean. So our A value is the amplitude. So this has an amplitude or a vertical stretch of 2. The negative sign that's in front is what is reflecting that. So this right here, if that is not negative, you do not have a reflection. The period is found by doing 2 pi and dividing that by your B value. So when I simplify this, I get pi over 2, 1/2 pi. So what that means is that the graph is repeating every pi over 2. That's the frequency or the period of the graph. And then the minus h here is a shift to the right of pi units, and the plus 3 at the end is a shift of 3 units up. All right, so then we do have a couple that we are going to make graphs out of. Here, I'm taking this K value. This is going to determine my new midline, the line that goes right through the middle horizontally of this graph. And it looks like I have something that just didn't get erased here, and I don't think, nope, I'm not going to be able to do that. So we're just going to ignore that gray line. Oh, sorry about that. We're looking at the yellow midline here. -1, that's because of this. And then sine typically starts at 0. Our 5 points, we have going up, back to 0, going down, back to 0. And then because A is 2, our amplitude is 2. So we're actually going up 2 from the midline and down 2 boxes from the midline. So sine curve looks like this red curve here. And that is one frequency or one period of that graph. All right, so we'll take a look here at the next one. This one has a negative sign in front. Sorry, let's get that adjusted. This is going to be a reflection, so we see that it's reflected. And then the minus pi over 2 is shifting our graph to the right. So normally our 5 points would have been here, 2, 3, 4, 5, and it would be ending at 2 pi. That would be the normal frequency or period of this graph. But everything here is being shifted. And so what started here originally is now being shifted to the right. And where we would have ended at 2 pi, that is being shifted to the right. So those are our 5 key points for our graph. I went ahead and drew in what this would look like if it was not reflected. Cosine starts at 1, 0, -1, 0, 1. And then I went ahead and reflected it. So this bold red line is our final graph. That's a reflection, and it is shifted to the right pi over 2 units. Last one is analyzing this graph and being able to find the period and the amplitude. So the midline here is right in the middle. So if you can eyeball that, you can do that. The other thing that you can do is you can figure out how tall this entire graph is. So from the 5, 1, 2, 3, 4, 5, 6 units. And if you split that, 1, 2, 3, you will find that midline. And that also gives us the answer to our amplitude, right? Because it is 3 units above that, and it is 3 units below. It's just going to be half of that entire height of 6 that we counted. The period is horizontal. That's looking at perhaps one peak to one peak, or maybe even a repetition of here to here. That would be another distance that you could look at. The easiest one is going to be the one I think that I outlined here. So from 0 to this spot here, which if we look down is pi. So that gap from 0 to pi is pi. So that is the horizontal distance. That's the period. Every pi, this repeats itself. All right, that's the end.